Nurina Afika, and today we are going to learn about one sentences. Let's start with the alarm clock. Physics help me to understand the laws that use the physical. Everyone use basic physics concepts to navigate in their daily life.
So, in this video, I'm going to talk about alarm clock. Of course, we are all wonder how do we use this physics concept in everyday life. So, let's begin. How your morning start with quantum physics. They say the cheaper electric clock, the alarm is louder and more annoying enough to wake us up, and the display is bright enough to almost be able to read it. Cheap as it is, this clock relies on quantum physics to be able to operate in at least 3 ways. The first one is definition of time. The second way of physics is in the very definition of time. The third, we might well know that the cheap electric alarm clock does not directly involve calcium atoms, and that's true. The clock marks time using the oscillating electric current coming out of the wall plug, which is designed to be oscillating exactly 60 times per second. But that oscillating current is itself regulated using quantum physics. Interesting, right? So, the modern electric power grid involves lots of different generation sources, coal and gas power plants, hydroelectric plants, solar and wind power, all of which must oscillate at the same frequency in order to getting all those disparate sources to produce current that alternates at exactly 60 Hz is a complicated process, and most modern power plants do this with the aid of time signals. The second way, quantum physics is essential for the processes that convert that oscillation current from the wall plug into a signal that tells the red LED to switch on and off in the right order to make the appropriate digits appear on the face of clock. This is accomplished using a variety of integrated circuits, mostly manufactured from the chunks of semiconductors, just like the third way, which is the most interesting. So, here we go to the third way, which is the most interesting part for me. The cheap clock relies on quantum physics has to do with the red glow of the digits that can almost see when we squint blurrily at it in the morning. Those glowing numbers are light emitting diodes, and the particular color they emit is the result of quantum physics. LED like the ones in my clock get their color from the energy levels of particular atoms, but from vast collections of atoms in solid chunks of semiconductors. A semiconductor can carry current under certain conditions by promoting a few electrons from the top of a low energy band to the bottom of the next band up, leaving behind some holes in the lower band. So, when those electrons drop back to the lower band, they emit light with the energy of the light determined by the band gap of the particular semiconductor used. Based on this video, the exact size of the gap, lastly, the red color that I see as I fumble for the snooze button is determined by the quantum physics of vast numbers of atoms come together and thus choose what color light something can emit, but how to change the electrical properties of a particular solid by mixing in atoms of the materials. Careful control of these dopants that can turn different chunks of a single block of silicon into different sorts of materials with different electric conductivity and even conducting electricity by different means. Butting types of materials up against each other lets chip makers make tiny little transistors that can switch the flow of current on and off in response to electrical signals. And connecting these transistors together lets us make complicated